For today's quiz, we want to talk about how power companies can measure the total amount of current coming out of their factory. The way that they do this is they use meters to be able to read how much is going through there, but there's no way that I could get all of the current going through this little meter. There's a little galvanometer, uses a small coil of wire. If I send too much current through there, it'll simply poof, go up in smoke. So how can you actually measure large amounts of current using a small meter? What we use is a very large conductor. We call these shunts. Now, this is a shunt that I'm making. Production shunts will look something like this. And you'll notice that the surface area of these pieces of metal here are in contact all the way around, and that's very important. So our quiz today is if I were to use a shunt, which is going to allow almost all of the current to go through here, and if I use a small little meter like this, I can connect it between these points, and what's essentially happening is just a little trickle of current will go through this meter while the vast majority of the current goes through this larger conductor. So our quiz for today is simply asking about this shunt. Let me show you this quiz. Fold it back so you can see it a little bit better. Here it is. As always, we want you to rate your confidence and then try to provide an explanation of why you think each of these configurations has more or less resistance. Let me explain it a little bit further. In other words, if I wanted to put a shunt across this meter, would I put it in this configuration, or this configuration, or as listed on the sheet here? I'll show it once again. So go ahead and write down your explanation. All right, so let's think about this. If we want electrons to go unimpeded through a piece of metal, and again, this is just a piece of steel that I cut. If we think about what configuration would give us the greatest amount of resistance, we can simply think of, if you're an electron and you're trying to go from one side to the other, the more interactions I have with the steel, which has a bit more resistance than maybe your copper or aluminum lines coming through there, the longer I'm in the steel, the more resistance I have. So this configuration from here to here would have the most resistance. And it wouldn't matter if I rotated it down like a flat piece like this. So in this particular case, it looks like to get the full length, number 1 and number 4 would have the greatest resistance. Now let's go ahead and put it this way. In this configuration, you can see that I just have to go across this little smaller length, and therefore it would have less resistance than if I had to go the longer length. And finally, if I wanted to have the least amount of resistance, I would put it in this configuration. So that electrons would only need to jump from this side to this side, having very little interaction with the steel, and they've got many different pathways. So they're not all lined up like in a tunnel that might back up. So this would have the least resistance in that configuration. So we would say number 3 would have the least, number 1 and number 4 are the same. It's just this versus this, right? You still have the same length. And the other two that we have left are number 5. So again, the greatest resistance, less resistance, the least resistance. And that is your quiz for today. And one more point, if you're still around, you'll notice that often meters on the bottom have 3 different ratings. You can do that using the same shunt. You can connect across these edges, are these edges or these edges? And that will give you different ratings of your scale. So that's just an application that we see every day. That's your quiz.